Okay, good evening, everyone. Welcome to our BranchOut Veritas Education Community Workshop on the field of robotics. I'm Caroline Lee, and I'll be one of your hosts for tonight.
Hi, I'm Lisa Sun. I'm another one of your hosts.
And I'm Lucas Shen. I'll be your final host for tonight.
So to introduce BranchOut a bit, we have a video that we're going to share with you guys. It seems like I'm unable to share my screen, so we can just describe the program.
Okay. We are part of the program BranchOut, which is a nonprofit program with Veritas education leaders that was co-founded by Dr. Yuxian Wu and Mr. Richard Wong in 2015. The organization has grown from 20 student volunteers to over 150 student volunteers in just 4 short summers. And our high school student mentors come from over 40 different schools across 4 states.
Okay, so it seems I'm able to share my screen now, so I can share the video with you guys right now. So BranchOut started as a peer STEM mentoring program, working at community centers, homeless shelters, and county summer credit recovery programs. We have since then expanded into a community outreach program to promote cross-cultural understanding by featuring cultural community heroes, creating research articles, and organizing community workshops. As an award-winning community engagement program, we have received endorsement from U.S. Congress, including Senator Tim Kaine and former Congresswoman Barbara Comstock. Additionally, our Innovator program won the U.S. Congressional App Challenge Award 4 years ago.
As part of BranchOut's goals to promote civil engagement, community, and STEM education, we're extremely glad to have you with us today. Robotics is a vast and multidisciplinary field combining both science and engineering. Today, we have assembled a diverse panel of experts to explore both the fields of robotics as well as its influence on other fields.
We are delighted to welcome our distinguished panelists today. They will share their expertise on robotics, how it's being applied to different fields of study, and its potential to shape our future.
Our panelist's name is Dr. Jaramillo. Dr. Jaramillo is an assistant professor in the Department of Weapons and Systems Engineering at the United States Naval Academy. At the Academy, her research focuses on the implementation of linear and adaptive controllers, more specifically for guided actuation of upper limb soft robotic exoskeleton systems, as well as the development of a soft robotic tooling system for corrosive environments with a biomedical focus. Through these projects, she continues to grow as a researcher and strengthens partnerships with other institutions via collaborative research.
Hi, everyone. That's a nice introduction. Can you hear me?
Yes, we can.
Okay. Just making sure. Sorry, if there is sound behind me, my dog is laying on the floor. I apologize about that. Digit.
To start this panel, we'll begin by asking some general questions. And if you have any thoughts, feel free to unmute and share them. Dr. Jaramillo, what sparked your interest in robotics?
Well, my interest in robotics came later in my career. I actually started my main focus has always been biomechanics. I didn't know that it was called biomechanics when I was in your age, but I wanted to be a doctor, so I want to pursue medical school, but I also wanted to be an engineer because my teachers told me how good I was. I was doing very well in my math science classes. Um, and I wanted to find something that kind of provide that interdisciplinary, right? I didn't go as clinical in that path. I went more in the mechanics path. So that's where my pursuit for engineering started. That's how I pursued biomedical engineering at the University of Hartford in Connecticut. And then I added mechanical engineering. I felt like at that time it was still a very emerging major. And I just felt like I needed to have additional fundamentals. And so I decided to add to mechanical engineering. So I end up doing 2 bachelor's degrees at the same time in engineering. I must say at the time, or even I think it's still happening, you either at some point in your junior year, most universities will start branching out the students based on their interests in the engineering program, especially mechanical, and you either go, the dynamics and vibrations, or the dynamics and controls, or the thermal sciences, the design, and you can miss control systems altogether. You can miss that component, the robotics and control component, which is what I did. I didn't know. I knew very, very elemental about what controls was. It wasn't my interest. I went the dynamics and vibrations route, and it was actually after pursuing my master's. I did my master's more in material science, and after I finished my master, I wanted to reflect on what I wanted to do next, because I felt like I needed to go back to my biomedical engineering roots. And that is where I went into the biomechanics and the control systems engineering. So I do more of the controls part, the feedback, the autonomy, rather than coming from the robotic side, right, of the design of the robotic system. But that's how I end up there. It was quite a crash course, because at the doctoral level you are told, oh, you need these undergraduate things that I know you didn't learn in undergrad because you went the other way, but you need to know them. So do it this summer so you'll be ready for your first class of graduate school in the fall. So that's how I started my work in control system, but I must say it's wonderful. Controls have been around since the 40s. And the thing with that is that control system feedback control is what I mean, right? The whole autonomy is old, it's not new. What wasn't there was the technology to catch up with it, right? So now that you have this ability to have systems that can respond quickly, right? That can provide you the feedback that you need in real time, very fast. Now you see all that being out there, right? Now you see the autonomy in the cars. Now you see the autonomy in surgeries. Now you see the autonomy in a device that can vacuum your floors and mop your floors, right? And they started with the Roomba, and the Roomba was all over the place, right? And now you actually have a sensor that is gonna first take a look at where you are, where is at, what are the obstacles, and then make a plan, right? So it's just the technology wasn't there. So as a professor now at the Naval Academy, I feel it's very exciting to see that what I'm talking about is happening, right? And there is more happening now. It's just an explosion of these autonomous systems, these robotic systems that are possible because of the technology. And then now you put that cherry on top, which is the artificial intelligence, the machine learning tools that are just making things even more challenging, complex, but also allowing you to design and be able to reach those high complexity tasks that you probably didn't think that you could do it at the time, so that's my trajectory. That's how I started. It was just biomedical engineering.
Yeah, so like I heard you talked a lot about control systems and how like you're really passionate and interested about it. So based on that, how do you think control systems are implemented? And what are some examples in control systems like right now? How are they like implemented into?
Control systems is feedback, right? Is the ability for you to be able to have a way to measure something, and then you want to guide something to do a task that you desire, right? So the having that ability to measure something using this device called a sensor will allow you to compare whether the task is doing what you want or it's not, right? And when that is not happening, you want to correct that, and you measure error, right, in the system. And that's very oversimplified controllers, but that's pretty much what it is. You have this feedback loop, right? So it's at um, the ability to have these sensors, the ability to measure, right? Whether you can measure by having cameras that can map the trajectory as your car is driving, right? Like can tell you to maintain this velocity at certain points, that allows you to maintain a specific distance between other cars, that will allow you to say, hey, you know what? You are supposed to be on this lane and you just cross to the other lane. So I'm going to beep to let you know that just happened and you are going to correct. Or I think there are other cars now that can actually correct for you, right? Like the Tesla can do a lot of things. And so that's what the control system allows you to do, is the autonomy aspect, right? So when you have a robotic arm and you want the robotic arm to perform a task, the robotic arm is measuring location, where it's at all times. It's also having a visual with cameras around it that are mounted so that it can see the space. And when you can see that pretty much anywhere nowadays. I was at a hospital one time and I wanted an ice cream, and everything was closed, but there was this ice cream machine. And I went to the ice cream machine and I press some buttons, I select my flavors, I select the toppings, and all of a sudden this robotic arms comes out, goes to a corner to reset and start the process of building my ice cream in a cup, right? So it's the same robotic arm that we have in our classroom in the Naval Academy that we are using for other things, right? The same type of robotic arms that more powerful, obviously, that Amazon uses to package, right? So it's just the coding part, the task, the analysis is really similar, right? In that sense, because you are now taking a system that has sensors, various different sensors, and what you're trying to do is you're trying to make that arm make an ice cream, make that arm pick a tool, make our arm take a package and put it on another place, so pick and place. But at the same, make that same arm cut, have a end effector, which is what it has at the end of the robotic arm, and make a cut while you're doing your surgery, right? So it's the same idea that you have this feedback, this constant feedback that allow the system to make decisions, right? And to make those decisions so that it can do the desired input that you select, right? meaning what are the tasks that I am set to do, and how do I do them? And if there is an obstacle, how do I make a decision to go and overcome that to perform my task, right?
So I found it really interesting how you talked about the applications in like cars or like Teslas, as well as in everyday objects such as like ice cream machines and also surgery. But since you're currently a professor at the US Naval Academy, what are some unique ways that you've seen robotics address a particular problem in regards to military applications?
So it's a big deal. Right now, the Department of the Navy, they usually came out with the goals of how do you want our military to look in the next 10 years, right? And one of the big components that the Secretary of the Navy had in this letter was the need for the military to work alongside robots, the need for have that companion, right? Whether it's in the water or in through terrain, is that ability to interact, right? A human machine interface, ability to be able to trust your robot to perform a specific task. In addition to that, the Navy is really vested in developing robotic systems that are going to be placed on the ships for repair, for defense, right? And so that there is a big push on having that integration of systems, that having that integration, and that's that ability for the human, for the military person and the machine to be able to work together for a goal. And lastly, we had, I think it was 2 years ago, we had a visit of an autonomous ship. It was docked in Annapolis, and it was fully autonomous. So that's the direction that the military is moving, certainly, without compromising on the skills that are being taught to the midshipmen, or to the midshipmen and cadets, to the military body, because that's always important, right? You don't want to be you want to trust the whatever robotic system you're working with, but you don't want to not be able to understand what is happening either. You don't want to be completely dependent on that, because like it's a machine at the end of the day, can fail when you need it the most. So
I think that's very true. Not to like put all your trust into one thing. I think it's really fascinating to hear like how far technology has developed to the point where we have an autonomous ship. That's crazy.
yes.
In regards to trusting robots and just like working to figure out ways to have a better companionship with robots, what are some challenges you faced when trying to create effective connections between robots and people?
Well, that's the thing that I was gonna say next. So there, because of the development of all these systems that are very integrated, um, it is very hard. As of now, I have tried, but I am still working on it, quantifying what does it mean to have a good human machine integration. Like, can you quantify it, right? Not subjectively, not asking you, how do you feel working with that robot, or do you feel the task was easy or was hard? It's more like, I want to put a quantity to that, right? I want to put that quantity so that I can then measure the situational awareness, right? And that happens even when you are not just in ships, that is in the air as well. That's another problem that we have. So the military right now, because they need to develop best practices to use these systems, they need to come up with pretty much a protocol on, okay, what is the situational awareness? How do we quantify that? How do we quantify this human machine interaction? Right? And that is still a problem that needs to be solved. Right now, for instance, I'm going to be working for the next year on a project that is going to look at a robotic arm. There is not going to be feedback in the sense of I am going to design a control system to implement in a robotic arm. No, I really just want to look at my achievement working with the robotic arm in different levels of autonomy, right? So meaning he's going to operate this robotic arm manually, and he's going to do a simple task. You always want to keep it simple. Or he's going to operate this robotic arm where there are some cues that the arm, the way the arm moves, and then he intervenes, and then the robotic arm intervenes, and it's almost like a tag team, right? Or he just lets the robotic arm do the task, right? And I want to see this, how these three scenarios play out, and then try to quantify how will I measure this interaction, right? So that is very important. That is right now, if there's a project that you want to work, that is right now an unknown, right? Until there are standards of how to do that, measure effective ways to measure that human machine interface, we are still not fully implementing any of these different systems fully on the branches of the military, right? Because they have to be that awareness. Another example that I want to give you is I work on a project that was looking at the pilots, right? And it was looking at, okay, the pilots are trained to have this situational awareness when there is an enemy aircraft. And when you are in reconnaissance, meaning you have no sensors in your aircraft that will allow the enemy to detect you. You are solely relying on a close communication that you have with somebody that is located somewhere else, that is looking at the screen and looking at the radar location, right? And looking at what is out there close to you. So right now, the way that works is when you are doing that kind of reconnaissance work, you are relying on somebody to provide you that feedback. Then when you have that feedback, that's when you make the decision, okay, he's gonna kill me and I better go back, or I need to really, what is called a scram, meaning I am leaving because I am about to get killed, right? Like there are two levels. So it's like, I better stop what I'm doing and go back, or I just completely cancel this mission because I'm about to be compromised, right? Right now, there is no way, because you want to safeguard that aircraft, that is, you want to keep it unknown. There is no way for that pilot to have any tools to know what is out there, right? So he relies in a very close communication that is outside where he is. What they wanted to do is, okay, what if we take the pilot out and we send an autonomous aircraft, right? There is no one there, but we don't want to compromise the information that we're gathering. So how does that autonomous system make the decision that, okay, this enemy plane is close, I need to go back and wait until the coast is clear, or no, I'm about to get shot and blown into pieces, I need to cancel this and just leave, right? So that again is that, how do we measure that? How do we ensure that the system is going to be able to make that decision? And until those systems have a handle on that situational awareness, that cannot be implemented. We cannot risk that, right? So that's just an example on what is the need.
It's really exciting to hear about these future plans. It's kind of like getting like a really cool sneak peek.
Mm-hmm.
Yeah, definitely. So I'll definitely be looking forward to updates on human robot integration in like Navy type stuff, like ships and all that. So a question that I have is, how do you take inspiration from everyday life when you're like just creating new robots or coming up with new ideas?
Well, it depends. I have to control myself because ideas come and go, but you have to be focused, right? Right now, I am really interested in more in the, going back to my biomedical side, on the medical aspect of communication. I am very interested in starting to look at human performance. How can we um, measure, and all about measure is almost like a human factors. That's what I like. How can I quantify the cognitive load when you are under severe stress, right? How, or whether that stress is psychological stress, or that stress is physically induced. In my case, it's physically induced. Like if I put you on a treadmill or in a bike or and I tell you, you are going to just run as fast as you can, and then I'm gonna, on top of that, I'm gonna be asking you questions that you need to answer, right? That you need to think about, or mental exercises. How can I measure how you're doing, right? Under that type of, how's your cognitive load at that moment during fatigue, right? So that's one aspect that I'm looking at. And I'm also looking at how do I implement machine learning now that the machine learning tools are blown up and there is so much out there. How can I implement those type of machine learning, use it as a tool to improve communication when you cannot communicate, when you are impaired, when you are a child, an adult that cannot talk, when you are that have muscle weakness that doesn't allow you to sign, to move as you would like. So what are the cues that I can observe from you that will tell me things that are happening to you, right? And I'm looking mainly on the aspects of pain. Right now, even when you take a healthy infant or a healthy toddler that doesn't speak, when they are frustrated because their toy disappeared, they cry. When they are in pain, they cry. But as a parent, and I know you guys are not parents, but your parents probably understand, you probably still cry. um, you understand that, okay, this cry looks more like frustration, this cry is like something is wrong. So in the same way, how do I take now somebody that might be showing signs of distress that are not me saying I am in distress? That would be too easy, right? But it's like me seeing that, okay, your markers, your respiratory rate, your heart rate are through the roof. Something is happening, and I would like to know what is causing that pain, or I would like to know, this event is about to happen if I don't stop it right now, right? So I'm trying to look at those cues that will tell me that someone is about to be in some sort of distress, right? Without reaching that distress level. And for me, that I know it moves away from the robotic, the actual robotic implementation, but it's more on the machine learning feedback control aspect. Now, in terms of the robotic component, I love exoskeletons. I think that soft robotic exoskeleton for the same application are um, a great solution, a great challenge to do, to improve and support um, a muscle weakness, right? And they can be used for rehabilitation as well, right? So it's like the same exoskeleton can be used to support you so that you can complete a task, but the same exoskeleton that can also provide you some passive rehabilitation and can provide you some active rehabilitation and can provide some active resist rehabilitation, right? To help you. And with the implementation of control systems and autonomy, the novelty of that is that it changes as you improve, as the user improve, right? So I am not saying that let's cut rehab sessions for individuals completely, and let's just harness them with this exoskeleton. But what I'm saying is that when you are in a process, when somebody's injured due to trauma, due to genetic conditions, whatever the reason, a stroke, whether it's an elder, it's a child, it's a young individual, a rehabilitation, a exoskeleton system, a sub-robotic exoskeleton system that can be portable, that can be autonomous, that can be configured for that individual, can be a great supplement for at-home rehabilitation, right? And it has shown, literature has shown that when you are in some sort of traumatic event or any sort of event where you lost the ability to um, to move, your muscles, certainly in any traumatic event, the muscle mass and the muscle properties certainly go on a decline, right? So it is important to start those therapies as soon as possible, right after the surgery, when you are clear to do it, after you are under control, right? It is important to start those movements quicker, because that increases your chances of recovery, right? What that does is, from a signaling pathway point of view, is that it actually starts the firing of those signals, and it starts to, if the nerves are not working anymore and they have been reattached, it starts sending that information, and the nerves start to grow, and some of that recovery starts happening. It doesn't mean that is seamless. It doesn't mean that it's not painful, but it's something that it is important to do. So I feel like I feel like that can be helpful in that sense, to provide that's extra rehabilitation component at home, when you are not, when it's cumbersome to go to a therapist or to a rehab center, right? There is a host of problems right now in the healthcare industry, where there is not enough resources, there's not enough infrastructure to support, whether it's people that have specific medical conditions, children or young adults, and also the elderly, right? You can even use the same exoskeleton. So in here you have these soft exoskeletons that can be used for rehabilitation. You can use something under the same lines and support a farmer working on the field, right? To be a harness, and you can take that same type of exoskeleton and use it in the military, to be able for the military to do longer hikes, more secure, without compromising their bodies, because there is a lot of um, physical damage that gets done, especially in the back, and because of these combat loads are keep increasing in weight, right? So you having a harness, an exoskeleton that can offload this, will be helpful for them, in terms of fatigue, in terms of ensuring that they are not hurt, and that will allow the military to be better prepared, right? So it's like this, you can apply this type of exoskeleton in so many different scenarios, that pretty much there is no limit, as long as the development is there, which is starting to be.
As someone who has observed family with movement struggles, like due to certain health conditions, it's really reassuring to know like how much research is like being invested to solve that issue now.
Oh, definitely.
Mm-hmm.
There was a big disconnect even when I was doing my doctoral studies on autonomy, control system, and then the development of the medical devices, so exoskeletons, and everything was open loop, meaning there was no feedback in that sense. And it's like, finally the two are starting to merge, and these two disciplines are starting to come together, realizing, okay, we have to be able to have this autonomy. We have to be able to have system that can change according to the circumstances, right? And it's still a challenge. It's still a challenge in the sense of the type of the inputs. It requires a lot of inputs, and that can cause a lot of wear and tear on the system. So it's not perfect there, but excuse me, but certainly much better than what it was. It is a work in progress, and all these technologies are still emerging. And I'm sure that when you guys go ahead and do the wonderful things that you want to do, you can be part of all this.
Yeah, so I think you just sparked my interest on like exoskeletons and all of that, how they can actually be able to solve like these mental health issues, and how you also said that like traumatic events can also lead to muscle loss or
Mhm.
muscle properties like decline. So I thought that was actually like very interesting, and I think you like sparked an interest in this field.
Well, there you go.
Yes.
Then apply to
Yes.
Carnegie Mellon. And their program, the robotics program, is one of the first programs that were there. Usually robotics was always buried in mechanical engineer, not electrical engineer, just like biomedical engineer was buried in those, or controls for any matter. And now you are seeing all these new programs popping up, like specifically on robotics. And I encourage you to certainly be part of that cutting edge technology that is happening, and that you can contribute, and you can see it, as you grow in your careers.
Yeah, I completely agree with what Lucas previously said. And I also found it really interesting how you mentioned before how robots can be used to detect like the subtle nuances of human emotions, so like cries and stuff. So, it must be really hard because human emotions and behavior are so multifaceted. So, just as a final question before the Q&A, what are some challenges that you have faced with past and present projects?
Challenges. Well, I am in a very unique position as a faculty at the Naval Academy, in the sense that our institution is primarily focused on teaching. We are not a research one institution, meaning a Carnegie Mellon, MIT, Virginia Tech, NC State. We're not a big research focus, right? When you look at those big institutions, which are great, their main focus of the faculty is to do research. They have huge labs with a lot of infrastructure and support. In my case, I am a one-man show, a one-woman show, in the sense that I have to be the one in my smaller lab. I cannot support this huge infrastructure. I mean, some of these lab, even if you go to John Hopkins, right, they have buildings that is just the lab, right? Like you in here, you have a very small scale lab where you try to do your work, always with the understanding that teaching is first, right? So we're very good at that. But the research take a second priority. So I cannot produce at the same rate as a research one professor will, right? That has 5, 6 graduate students, one or two postdocs, right? And you have a team that you say, okay, go, right? Um, so in that sense, I cannot the challenge is I cannot go for those big grants, those big proposals to have the funding, because I cannot spend it. I just don't have the way to spend that amount of money, compared to our one institution. So that in that sense, the my colleagues and I are rate of getting our work out, and working on our research is definitely slower than if you compare that to a more of a research institution. So that's probably one of the biggest challenges, trying to say, I have interest in all these areas, like I was telling you before, but I need to pick, what am I doing this year? Am I going to focus on this area only because that's all I have, right? Because my priority is my teaching, and our teaching load is much, much higher than when you compare a teaching load on a research institution, um, where you can actually buy yourself out of teaching to focus solely on your research. So it's the challenge is trying to have that balance of you certainly cannot compete with those type of at that level of research work, but you are trying to do meaningful small scale work, right, where you can bring in and out students as the time goes by, right? So I like to bring students early on, and I can keep them for maybe 1 or 2 years, and then they graduate and leave, right? And our students do leave because they all get a job after they graduate, they get commission, they leave, and but I have already in the pipeline another student that was learning from him that is going to help me, but I cannot expect as much because these are undergraduate students with 20 credits, right, that they are working on every semester, versus a graduate student or a postdoc that is hired solely to do research, right? So the expectations have to be retuned, right? Because the feedback it tells me so, right? So I have to correct for that. So yes, our the way that we evolve in our research is a very slower pace.
I think that the fact that the Naval Academy is not research focused leads to some really interesting challenges. So now we will open up the panel for any questions from the viewers. So please feel free to type your questions in the Q&A box.
So
It seems.
oh
Oh,
yeah,
sorry.
go ahead. I am reading the question. I wasn't sure how you want to handle this. You
Oh,
go
you
ahead.
can just say like an answer for each question you see or each question you want to answer.
Okay. Well, the first one is about the patent that I have. So that this was a work that I did with the United States Coast Guard Academy. So we brought students from the Coast Guard, cadets, and the midshipmen, and they didn't kill each other, which was great. But this was the purpose of this is how do we develop a system that can help us make repairs in a ship, right? And for the Coast Guard, they go on areas that are very inhabitable, and I'm sure the Navy does too. But their main focus was, okay, what if we have a part that broke and we need to repair it? How do we go about doing this, right? So it was all about having a 3D printing system on site in the ship that will allow to print up a modular tool that you could use to repair something, right? So that's what we did. That modular system, then I obviously, because of my biomechanics and my interest, I took it as, okay, what if you get injured? It's not that the dishwasher in your ship broke, it's that somebody is injured because an accident occurred, right? How would you handle that? And it was focusing on, okay, you definitely need to call for help, but help is not like 20 minutes away, it can be days away. In the meantime, what do you do? So what we developed was a tourniquet system that you could print, right? A system that will try to keep the wound in place to prevent bleeding while you are taken to a facility to get treated. And that's where this patent came about. So I hope that answers your question. What is the next step forward in the field of robotics? Certainly, the thing to watch is having is a fine line of having robotic systems that you can recognize that they are not people, and how do we handle that? How do we handle that interaction? I think the human machine interaction is very important. um, I don't know if you are aware, but or maybe you guys have them already, but there is a lot of robots now that are made for kids, to be companions, for kids that are autistic, to be their companion. Sometimes I want them too. I'm like, should I get one? Because they are cute, they are engaging, they are sweet. But how do we keep that fine line between I'm interacting with a robot and this is not another human, right? How do we, from it's more of a safety concern, an ethical concern, like how do we ensure that we teach a child that there is a difference, and there is, you know there has to be a fine line of where this relationship stops, because you need to focus on more human relationships, right? So I feel like that is something, the ethical implications, if you want a specific answer to your question, Brian, that what are the ethical implications of implementing robotics into our daily life? Like, how do we develop policies, develop standards where we ensure that we don't cross some lines of, in relationships? And it's because I for example, I have used ChatGPT. Have you used ChatGPT, guys? I'm sure you have. I have used ChatGPT, and I remember one time I was trying to understand something, and I asked ChatGPT, and he get chat. See, I call him he already. Gave me an answer, but I wanted to know more what he meant, so I did it again, and then I did it again. And at one point, I went, "Oh, I'm so sorry, Chad." I literally said, "I'm so sorry, Chad. I need to ask." And he's like, "Wait a minute." He could care less that I asked him the same question 100 times. He is a tool. He's not a person. So if that happens to me, I can only imagine when you see this, like the ABB robots, or you see the I forgot the other name, Noxy robot. These are made for children, right? And they are for children with special needs, for children with that need the help in their schooling. These are little children that don't know what it means to, they are building relationships, their connections are still firing and building, right? So how do we ensure that there are best practices for doing this? How do we safeguard and preserve our individuality, or as humans, and make sure that we understand that these are machines, right? That they are not, they don't have a soul in them. Is what I'm trying to say. That to me is what we need to look next, especially with the explosion of AI. So we need to be careful. What is the most rewarding part of what you do? The most rewarding is, to me, is seeing the achievement get commissioned, get sent to get what they want. So the midshipmen, they, for the most part, they pick the branches they want to go into, and I'm very fortunate to be surrounded. My students always get what their first or second choice is, and just seeing those future officers, seeing how, when I'm in the classroom, I am teaching the future leaders. These are people that are going to end up being the admiral or the captains, that are going to have a fleet, that are being developed in different aspects, and I contribute to one of them, which is the academic aspect, to lead a group of people and to make decisions. And so that's very rewarding in that sense. And what I tell them, and what I will tell you, all of you, is that the key to grow always is for you to always have this mindset of being a lifelong learner, because things change. When I started, my colleagues and I, like, we're like, when we were doing our PhD, AI machine learning was like a thing that computer science did. Like maybe I went to a seminar about machine learning. I remember going to one, and the guy was doing a computer vision project, and he like was looking at pictures in a bathroom. And it was funny because like the soap, the machine decided that was a dinosaur, and obviously it was wrong. But that's how far we have come, right? Now you have chat GPT answering questions, right? And before, like, this recognition was still in his infancy. But I think that the ability for you to keep up with the technology, to keep up with your field, whatever path that is, and the ability for you to teach yourself new skill sets that are going to always um, keep you on top of your game, on top of your trajectory is the key, right? The key for me, for my colleagues to be able to adapt this AI, to be able to look at these algorithms and start implementing them. Um, that comes from the fact that we are always challenging ourselves, we are always improving ourselves, we're always learning, right? You don't want to be just doing the bare minimum. You want to be hungry. Stay hungry. That's what I will say. Which university do you think will be the best for
Oh,
learning more about robotics? I think that Carnegie Mellon, there are so many right now. It has a great robotics program. Obviously, MIT it has a great robotics program. The Naval Academy has one of the first robotics programs in the country. So you said that I was from the weapons and systems engineer. We changed our name. Our name is Weapons, Robotics, and Control Engineering. So when the student join our major, the major is Robotics and Control Engineering. But what I will say is that you want to go to a school as an undergrad, you want to pick a school that focuses a lot on undergraduate education, is the best school that you need at the moment, because there are so many opportunities for you to use your summers. There are so many research experience programs that you can apply to and be able to go, where you can have those 10 weeks or 8 weeks of experience in other institutions. I am not a big fan, but this is just me personally, of bigger institutions for undergraduate, because the undergrad students get lost in that maze. Because frankly, the priority is the graduate student and the research, right? So unless you are exceptional, is not very common for you to come into a lab and join as an undergrad. So I will say, as a first layer, a smaller school, or probably the best way to address this is to when you go and you start deciding on where to go and you visit these universities, you should ask very directly, what is the experience of undergraduate research? Because you're going to see all these labs that are fascinating, that are with the best equipment that you can dream of. But that doesn't mean necessarily that you are going to touch it. That doesn't mean necessarily that you are going to be part of that. So it is important for you to understand what is the university, or what is the department, or if you're looking at a specific major, how do you work with undergrad? What are the opportunities for undergraduate research, so that I can apply what I am learning in the classroom, right? And you can see that also in the classes themselves. How much hands-on experience do you have, and when does that start? Right, nowadays there is so much research done on engineering education, for instance, and one of the things that works is putting the students from freshman year doing something hands-on work, very simple, that you don't know much. I mean, I know you think you know a lot, but you know very elemental, but putting you to work, discovery, allows you to learn more. And as you go in your sophomore year, in your junior year, you are getting all that experience. And by the time that you start your capstone year, right, your capstone project, you have this experience of these past 3 years that will allow you to learn, right? To know, to have that logical thinking, that critical thinking, to be able to tackle a problem. So I feel that that to me is very important for anyone, not just the military, to learn. It took me a while because when I did my education, that wasn't the way it was taught. So it is hard to do, but I feel like I can see it in my child. I can see it in my students. When you start attacking that from an early age, I'm sure you guys are challenged in your high school. Is a great gift. It's the best thing you can have, the ability to be a lifelong learner. So that's what I will advise you. Um, oh, advice for a student. Oh, sorry. Do you want me to keep going or no?
Oh, sorry, we're like running out of time. Sorry. Dr. Jaramillo, it's been very enlightening to like hear this sort of new concern about like the ethics of machine relations instead of what I've normally heard about copyright issues and plagiarism. And also it's been like super refreshing to hear like advice from somebody in like the professional field on how to take a step forward in research and education in robotics specifically. This is for everybody. Thank you all for your thoughtful questions. And thank you to Dr. Jaramillo for sharing your expertise.
You're welcome. And, if you have any questions, you can always reach out. My email is if you look at the website, I am there somewhere. My email is there, and you can feel free to send me an email if you have any questions. Okay. It was a pleasure. And thank you so much for the invitation. I hope I was able to answer some of your questions and provide some insights as to the robotics and controls field.
And that concludes our panel discussion. Thank you once again to our outstanding panelists and to all of you for attending. We hope this workshop has provided valuable insights into the fascinating field of robotics. And if you'd like to learn more about BranchOut and our future panels, please check us out at www.velbranchout.org. I'll repeat that, sorry, www.velbranchout.org, or like us on Facebook at Veritas Education Leaders. Dr. Jaramillo, if you could stay so we could take a group photo, that would be amazing.
Oh, sure.
As for everybody else, good night.